Hello everyone, I am Saswati Paramita, going to present our work on improving the performance of heterogeneous LiFi-WiFi network using a novel link aggregation framework in RISE IIIT Delhi. This work belongs to WERCOM Lab and Center of Excellence LiFi IIIT Delhi. Our main motivation towards this work is that day by day, the data rate requirement is increasing. Therefore, the available Wi-Fi spectrum is one of the challenge to serve more users with higher data rate. Therefore, Light Fidelity, that is LiFi, is one of the alternative technology is used as the counterpart of the Wi-Fi for providing higher data rate to the user. In general, LiFi provides data rate in the range of Gbps. Therefore, by using both the technique LiFi and Wi-Fi together, we can provide higher data rate to the user. In addition, if we are using link aggregation is one of the process which also provides the data rate to the user concurrently from the LiFi AP and Wi-Fi AP to improve the performance of the network capacity and other parameters such as reliability, delay, and reduce number of handovers. Main objective behind this work is that to improve the quality of service in terms of average data rate for the link aggregated heterogeneous LiFi-WiFi network by proposing novel algorithms such as link aggregation SINR and link aggregation EQoS. Before going to explain detail, let me introduce LiFi little more. LiFi is a technique which is using illumination and communication together by existing infrastructure of the illumination system inside the indoor scenario. Let us take one of the scenario like this. In this scenario, we have taken 5 x 5 x 3 size of room, and in that room 4 LiFi APs are installed at the corner of the rooms, and one Wi-Fi AP is installed at the center of the ceiling in the room, and the users are mobile inside the room. Here we can observe that the users which is not present in the full field of view of the LiFi AP, those users may get the lesser data rate from the LiFi AP. Therefore, the user requirement is not achieved in this case. Basically, to improve the data rate requirement for this user, we are proposing the algorithms based upon the link aggregation technique. Link aggregation is the technique which is providing the rate from the LiFi AP and Wi-Fi AP together. That means the user will get the connection concurrently from the LiFi AP and Wi-Fi AP. Therefore, this network is known as link aggregation enabled heterogeneous LiFi-WiFi network. In this network, we are applying two proposed algorithms, that is LA-EQoS and LA-SINR, to improve this rate of this user. In the first algorithm, we are just assigning link aggregation to all the users present inside the room. That means all the users will be connected to LiFi AP as well as the Wi-Fi AP, and this G mu alpha is the connection variable, and the rate of the users will be calculated by using this formula, where the beta OB is nothing but overhead for the link aggregations we have considered here, which is saying about the packet reordering and synchronization will be happening at the central controller, which is controlling all the APs. Those effects have been considered in this work. In the second algorithm, we are not taking all the users into the picture, because if we are providing link aggregation to all the users, unnecessarily Wi-Fi AP will be overloaded. Therefore, we have used the algorithm here to find out the users who is actually required the link aggregation. That means the minimum data rate in those users are not achieving. So for that, we have first analyze the algorithm by finding the NLA value. We are able to apply the algorithm in the way that those NLA users will be only allocated the connection from both the APs like LiFi and WiFi AP. Other users will be connected to the LiFi. So in that case, we observe that our performance of the LA-EQoS is providing better as compared to LA-SINR. Let me discuss about the results, what we are getting in this case. Already I have mentioned, first of all, we have analyzed the number of link aggregated users based upon total number of users present inside the room. Let us take one of the example here. Let total 10 number of users are present in the room. And in the exhaustive search way, we found that the minimum link aggregated users, if 4 number of link aggregated users will be chosen for total number of 10 users, we found that NLA value equals to 4 is providing the minimum or lowest outage rate and outage probability and a higher maximum average throughput. Therefore, in this way, we have decided for different number of total number of users and NLA combinations to analyze these two algorithms. We observed that in the case of average data rate analysis, here our proposed LA-EQoS is providing better throughput as compared to LA-SINR, our proposed first algorithm, and the hybrid network. Hybrid network is nothing but here the user will be connected either of the AP, either a LiFi AP or Wi-Fi AP. In this case, we also analyze the outage probability and coverage probability. We observe in the case of outage probability for different number of N and NLA value, our proposed LA-EQoS is performing better than our proposed LA-SINR, LiFi, Wi-Fi, and hybrid network. At the end, we observe that our proposed LA-EQoS algorithm also performs better in case of coverage probability. That means our LA-EQoS is providing more coverage as compared to LA-SINR enabled heterogeneous LiFi-WiFi network and standalone LiFi network, standalone Wi-Fi network, and hybrid network. For the predefined quality of service requirement of 20 Mbps. Finally, we conclude that our LA-EQoS algorithm is performing better than the conventional network and LA-SINR based heterogeneous LiFi-WiFi network. Finally, we also achieve that our LA-EQoS enabled heterogeneous LiFi-WiFi network provides quality of service of 1.5 times higher than the other networks. In other way also we found LA-EQoS enabled heterogeneous LiFi-WiFi network provides 100% coverage for n greater than 16 and 80% for n less than 16. We also would like to thank Mighty to providing partial financial support to do this work. Thank you. This is my contact. If any doubt is there, you may raise to me. Thank you.